Another one of the very useful rules in calculus, product rule. Corny. There we are, we have a product there. Well, that's easy peasy. What we'll do is let's differentiate, and then multiply them out. There we are, there is our derivative of that product. But hang on, I'm sure teacher said something about multiplying it out first. Let's have a look and see. So we've multiplied it out first, then we differentiate. Hang on, this is a bit of a puzzle. We've ended up with that result, multiplying out first, that result differentiating each separately. That comes from that which comes from that, so these should be exactly the same, and they're not. Yes. Great. That's correct. Incorrect. We can't do that. I'm sure you'll remember that your teacher said you must multiply out first before you differentiate. Oh, but hang on. Have a look at this one. This is great if we have to multiply this out first before we differentiate it. Let's see if we can find another way. And we do. Luckily we have the product rule. Let's have a look at some products. There we are. Y equals x minus 2 times x plus 3. Bracket times bracket. Y equals uv, where u is the first bracket, v is the second bracket. Bracket times bracket. Y equals uv, where u equals the contents of the first bracket and v equals contents of the second bracket. Bracket, well, you may not realize, but that's also a bracket, square root sign. That line across there means bracket. So therefore we have bracket, bracket. This is like the house you remember. So we have y equals uv. U is the content of the first bracket and v is the second. X sine x, yes, much the same thing. First times second. U is x, v is sine of x. Now we can have it in functional notation too. H of x equals bracket times bracket, where h of x equals f of x times g of x. You might have wondered why I've used h of x instead of f of x. We normally always use f of x. But I didn't want to confuse by having an f of x there, then an f of x in the formula as well. We can have h of x, k of x, z of x, whatever we like once we define a function. So h of x equals f of x times g of x. There's your f of x, there's your g of x. X minus 2, x plus 3. Same thing there. F of x, g of x. F of x, x minus 1, g of x, the square root of 1 minus x squared. Be careful. When we talk about differentiating that, remember that that is a composite function. You'd need the chain rule to differentiate that. X sine x. F of x is x, g of x is sine x. Right, so let's have a look at product rule. Let's actually have a look at the definition of product rule. Given that y equals u times v, u and v are functions in x. There we are. Derivative of y with respect to x, dy by dx equals derivative of u with respect to x, derivative of the first factor times the second factor plus the first factor times derivative of the second factor. So each gets a chance to be differentiated. Each gets a chance to lie fallow. There we are. There's the shorthand often used at universities. Y prime equals u prime v plus uv prime. Quite a useful shorthand. And to sum it up, product rule says derivative of product uv, derivative of u times v plus u times derivative of v. Here it is in functional notation. Derivative with respect to x of f of x times g of x equals f prime of x, the derivative of f of x, times g of x, plus f of x times g prime x, the derivative of g of x. Here's our first example. Let's do our first example now. Bracket times bracket. So there's your u, there's your v. There's the summary. U equals x cubed minus 2x and v equals 5x plus 3. There's our formula. So, we expand it into this question. Du by dx in red is 3x squared minus 2 because we've taken u and we differentiated x cubed minus 2x to 3x squared minus 2. And we've left v as it is, plus u as it is, times dv by dx, so we've gone to v and we've differentiated to give us 5. Simplify, multiply out the brackets, add like terms, and there we are. Now some of you may say, oh hang on, that's one hang of a long way around to do something. Why didn't we just multiply these out and do it that way? Much easier. Have a look at that. 2 lines instead of all this lot. But remember that first example which gave the minion a headache? We're getting on to them, hey? And you cannot use multiplying out to do it. So let's start with a simple example. Let's go back and let's not use that one. Let's have this way, just so we practiced on a simple one. Alright, let's have a look at the next one. H of x equals x times the square root of 1 minus x. Notice we have to write that as 1 minus x to the half. There we are. H of x, f of x times g of x. F of x is x, g of x is the square root of 1 minus x, or 1 minus x to the half. There's our formula. There is our product rule. So let's expand into this question. There we are. F prime of x. Well, f of x is x, so f prime of x is 1. G of x. Well, there's g of x, so there's g of x. Plus f of x. Straight f of x. 1, just x, times g prime of x. Now this is where we have to be careful. Remember the warning a little bit back. Here we are here. Now have a look at that. There is our chain rule. Differentiate the outside, so therefore half times the bracket to the negative half. There it is, half times the bracket to negative half. Multiplied by derivative of the inside. Derivative of 1 minus x is negative 1. There's your chain rule. Now to simplify that, we need to get rid of the negative exponent. So there we are. We'll do that. Notice the 2's gone below. Negative has changed that to a negative. X stays above, and it's 1 minus x to the negative half above becomes 1 minus x to the half below. Common denominator. So we now have bracket times bracket. Now those two multiply together will just give us the contents, 1 minus x. And anyway, there's our final answer. Next question. Fairly similar to the previous one. Once again, we're going to have to take this and write it in a slightly different form. After this, we'll do quotient rule, and then we won't need to. There's a shortcut to do this. Right, so we're going to write it as a product where we now have to introduce the negative exponent to bring that to the top. There it is. There we are. U is the x and v is the 2x plus 1 to the negative 1. There's our formula. There we're relating it to this question now. Du by dx, so therefore du by dx is 1 times v, there we are, plus u, so u is x, times dv by dx. Notice once again we have a chain rule situation. So we're going to have derivative of the outside function, multiply down, 2x plus 1 to the negative 2. There it is there. Times by derivative of the inside, which is 2. And there's your chain rule. Now, to simplify that, once again, we're going to get rid of the negative exponents. There we are, like that. And we find a common denominator, and it ends quite simply as that. Isn't that interesting? It's gone to a very simple answer. Oh, we've seen this before. There's our horror. Well, let's have a look at this. What we do have here, notice, is that we have a composite function and another composite function. So we're now going to end up with two chain rules. What I'm going to do in this case, just to make life a bit easier, is I'm going to take each one and differentiate it. So there we are. There's our u, there's the derivative. There's our v, there's the derivative. You can check it out by chain rule. So now, there's our formula. So we're going to start and we're going to say du by dx. Well, there's du by dx. So that whole bit there goes there. There it is in red. Times v. So times v. So it's just straight times there. Plus u. So now we're going to reproduce that there. Times. And we're going to go dv by dx. There it is there. Now in order to simplify something like this, you could multiply it out, but then you're getting right back to the same horror as the original. But you won't need to do that in the applications of calculus, if it's an equation or whatever, because remember we need to factorize. So I'm going to look at this and say, well, hang on, there are two terms and there are two common factors. I'm getting trigger happy. This is a common factor there, that to the 9, and that is a common factor to the 14. So I'm going to take them both out, to the 9, to the 14. From this one, that goes, I'm left with the 10, the 12x squared minus 3, and I'm left with just 2x plus 3 to the 1, because 2x plus 3 to the 14 has gone out. Plus, this one here, that bracket to the 9 has gone out, so therefore I'm left with that bracket to the 1. There it is there. Times, alright, that's gone out, so I have 30. There we are there, 30. Written in the front just for convenience, mathematical neatness, I guess. And multiplying it out, there's our final answer.